And here we go into a mean value theorem type problem. Very typical, found in textbooks a lot of the time and on tests. Let's do this. Given g of x and the interval provided below, can the mean value theorem be applied? 1. If so, find all values x equals c on the interval guaranteed by the mean value theorem. Okay, all right, one step at a time. If the mean value theorem can be applied to this function on this interval, the question is really, is g of x continuous and differentiable? I'll abbreviate that on 2 is less than or equal to x is less than or equal to 8. So on any A, B, or BC exam, all you typically need to do is just state yes or no to that. So 3 plus 8 over x. Now, just so that you've got an idea roughly of what's going on there, the only place that this is not continuous is at x equals 0. So I would just say yes, the MVT can be applied. So it can be applied since, just formally writing this out, I could be typing this, since g of x is continuous and differentiable on 2 is less than or equal to x is less than or equal to 8. You might be like, well, I don't believe you, Mr. Groden. Well, okay, the only place where this is not defined is at x equals 0, and that's nowhere to be found on this interval. So we're continuous. If you were to take the derivative of this thing, just for giggles, g prime of x equals, well, 3 goes to 0. This is 8x to the negative 1. So its derivative is negative 8x to the negative 2, which is equal to negative 8 over x squared. That right there, that is completely fine on this interval. Like, we will get derivative values for all values between 2 and 8. Right? So, yes, we are continuous and differentiable on the interval. Next, if so, we said it was, find all values x equals c on the interval guaranteed by the mean value theorem. Okay, what are these values that are guaranteed by the mean value theorem? The mean value theorem guarantees that there must be some c value or values between 2 and 8 such that the derivative of, I'm calling it f. Oh, geez. Call it g. Such that the derivative of g at some c value or values is equal to the slope of g over that interval. So that'd be g of b minus g of a, just writing it out formally, all over b minus a. Essentially, the slope over this interval is equal to the slope at some point. So now we just fill in the pieces here. We don't know what c is, but we've got negative 8 over, it's normally x squared, right? So I'll call it c squared, because you're saying at the x value called c. All right, you could call it x as well. That's equal to, now we're going to plug in g of 8 minus g of 2. Again, what we're essentially doing here is finding the slope between 2 and 8, the average rate of change, all over 8 minus 2. So we're going to patiently do those calculations and find our value. So negative 8 over c squared, again, that's the derivative, is equal to g of 8. Well, that's 3 plus 8 over 8. That's 4. That's nice. Minus, let's plug in 2, right? G of 2. 3 plus 8 over 2 is 7, right? Because 8 over 2 in most places is 4. And 3 plus 4 is 7. 4 minus 7 all over 8 minus 2. All right, we're almost there. So negative 8 over c squared is equal to 4 minus 7, negative 3. 8 minus 2, 6. Let's simplify this down. Negative 8 over c squared is equal to negative 1/2. So let's do a little cross multiplication, shall we? We're going to get a nice answer. So we'll get negative 16, 2 times negative 8. Negative times c squared, negative 1 times c squared is the opposite of c squared. The negatives drop. We'll get 16 equals c squared. And you'll actually get two answers. You'll get c equals plus or minus 4. Now, remember, the mean value theorem guarantees such an x value only on the interval from 2 to 8. So our answer is c equals 4, since negative 4 is not on that interval. So, I repeat, it's all about understanding the main concept, which is the derivative at a point is equal to the average rate of change over the interval you're given. Then just plug in your values. Follow what this tells you to do. It says take a derivative, set it equal to the slope on that interval. You've just got algebra then the rest of the way. That's all. Awesome. In another video, I'm going to make this one a short one. In another video, we're going to go over a more challenging type of mean value theorem application, one where you actually have to use the mean value theorem to prove that a slope happens on an interval. These are typically done with tables of data. I hope you join me for that one. I'm so glad you joined me for this explanation. Peace.